Hello! We're here today to talk about Venus, which is sometimes referred to as Earth's twin. We're going to see that Venus is similar to Earth in a lot of different ways. Venus is named after the Roman god Venus, and the Greek equivalent to Venus is Aphrodite. So, the goddess of love. The symbol here is a depiction of the hand mirror of the goddess. It's also sometimes used to show women. It's like the female symbol, again, probably because of the associations with Aphrodite and her hand mirror. So, we're diving into the brightest planet in the night sky. Venus is really close to us compared to everything else. It is also really, really reflective. Venus gives back a lot of the light that it receives, and so it's something that has always been really visible and really present kind of in the world. It was a huge, huge source of science fiction in the early to mid 1900s, even up to like the 1960s, 70s, 80s. We see a lot of sci fi involving Venus because by that point we knew that Venus is covered in a really thick layer of clouds that we'll talk more about in a minute. And so there was this idea that, like, okay, there's all of these clouds, but what if underneath the clouds there's a balmy, beautiful, lovely planet with oceans and swamps and all sorts of weird aliens and things? So Venus has always been a kind of popular source for imagination. There is a movie for Spaceship on Venus. The entire movie is available on YouTube if you want to watch it. I'm not going to play it here, but it's a really cheesy 1960s sci-fi movie about, like, what if we went to Venus and it turns out there are already whole civilizations there that were hidden from us in the clouds? So Venus was a place that we were interested in. It's something that has held on to our imaginations. It's really, really similar in size to Earth, and it seems like, yeah, that should be a place we want to check out. So in 1962, the Mariner 2 mission launched, and it flew to Venus. It had its first flyby in December of 1962. There's a GIF showing kind of the path that it took. And it found that the clouds were actually lower in temperature. It was pretty cool there, but the surface was extremely hot. Venus is the hottest planet. Venus is hotter than Mercury is for reasons that we're going to discuss. Even after Mariner 2, though, Venus continued to hold on to our imaginations. Again, I'm not going to play it, but the song, The Final Countdown, if you listen to the lyrics, a lot of it is about, like, what if we went to Venus? The countdown is the countdown to launching a ship to go to Venus. So here is a true to size comparison. You can see that Venus is just a tiny bit smaller than Earth, and it holds a lot of similarities in the way that it has behaved. Things that we can tell have happened on Venus are really similar to things that could happen or have or will happen on Earth. So there's a lot of similarities, which is why we call it Earth's twin. Some facts about Venus: it does have an atmosphere like Earth does, and unlike Mercury, Venus is known for having a really thick atmosphere that is mostly carbon dioxide. And carbon dioxide, you may have learned, is a greenhouse gas. So Venus has a runaway greenhouse effect, which keeps the temperature of pretty much the entire planet at about 800 degrees Fahrenheit, on average of 427 Celsius, and a pressure of 90 atm. That is, the pressure on Venus is 90 times more than it is on Earth. If you've ever, like, been flying in an airplane or have been deep underwater and you feel like you need to pop your ears, that's an effect of pressure. So imagine you were 90 times the amount of pressure. It gets wild. It's a hard thing to imagine. Um, we have taken pictures of Venus in ultraviolet. Here's one taken by the Galileo spacecraft, and then some colors were added because remember, ultraviolet is not something that we can see with our eyes. And so we add in some color to show us the cloud structure. And it turns out that these clouds have distinct shapes and follow patterns. And really, we give them the credit of this greenhouse effect. So pause and think for a second. Do you know how a greenhouse works? How does this structure keep plants around and alive in the winter? And it's because of the glass. It traps heat. Heat comes in, but it is unable to escape. The same thing can happen on a planet. Greenhouse gases in an atmosphere, like carbon dioxide, like H2O, like water vapor, these cause heat to become trapped. So we get energy from the sun, or any planet gets energy from the sun. It hits the surface of the planet, and then it re-radiates. It goes back into space. We saw this when we talked a little bit about the seasons on Earth, how the heat gets re-radiated, but not always the same every month. But if you've got a lot of greenhouse gases, it's like the edge of the picture all the way on the right, we trap that heat. It is unable to escape, and it ends up just kind of bouncing around in the atmosphere. The Earth has a little bit of a greenhouse effect, and it's good that the Earth has a little bit of a greenhouse effect. If we didn't, we would all freeze to death. Earth's greenhouse effect is getting worse. That's what people talk about when they talk about climate change or global warming. Too many greenhouse gases, and more heat is going to get trapped. That's what happened on Venus. We say Venus has a runaway greenhouse effect because there was so much carbon dioxide in the atmosphere that essentially all of the heat gets trapped. And the new sunlight coming in doesn't even make it to the surface. It gets bounced back by the clouds. That's why Venus is so bright in the night sky, because all of this light and heat coming from the sun gets bounced by the clouds and just reflected immediately. All of the heat that's already there is bouncing constantly between the clouds and the surface, keeping Venus at that 800 degrees. So if we look at the surface of the Earth, or of Venus, excuse me, if we peel back the cloud layers and see what's going on the rocky surface, we can see a long history of volcanoes along the outer layer. Venus clearly has some lava flows. There is some evidence of craters, but Venus, covered in volcanoes, is constantly resurfacing. And so a volcano erupts, that lava flows out, and any crater that was going to be on the surface is now covered in lava, and it's as if it was never there. So like Earth, Venus is kind of constantly resurfacing, which makes it hard to tell how old the planet is. Thanks to Mercury and Earth and the Moon, which we can date, we can safely assume that those things all formed at about the same time. So probably Venus in the middle did too. There are some craters that we can see on Venus. This is the crater Aurelia, which is about 20 miles in diameter. It was imaged by a mission called Magellan. And I want you to notice the way that things have kind of moved around it. And after you complete the virtual part of the crater lab, I want you to think, what might have caused it to be asymmetrical? Why would there be lots of stuff coming out on one side of the crater and not a whole lot of stuff on the other side of the crater? Here's another one, the Adams crater. And this one, we can tell, melted. The long kind of tail that it has, Venus is so hot, a object came and hit Venus, caused there to be a crater, but then it's so hot that things melted. It maybe caused some lava to erupt, and it's got this long tail from stuff flowing that was melted. We can see other areas of Venus that have these interesting features on them. This is called the Baltus Vallis, and it looks kind of like a river channel, right? It looks kind of like there could have been flowing water here. Probably it wasn't water, probably it was liquid carbon, but we do see areas where something was flowing on Venus. Here's another spot, the Alpha Regio, where again, you can see some kinds of flows. There was stuff that was moving. So could Venus at some point have looked a little bit more like Earth? Could it have had more water? And if it did, what would have happened to all of that water? It's got these like riverbeds, and it's got regions that look like they held water. like regions on Earth or even Mars, but clearly there's not liquid water there now. It's 800 degrees. So what happened to it? And to think about that, we have to think about the early sun. When the sun was first forming, it had to get really, really hot all of a sudden to start fusion. And so if you look at this graph, there's the vertical line showing the present age, and we can see how things have kind of stabilized to where they are now. But earlier, the sun was a little bit smaller, it was a little bit cooler because it hadn't had enough time to build up a bunch of fuel. It had one immediate, like, boom, it's hot enough for fusion, and now, like, okay, let's settle down and get fusion rolling. Since then, it has continued to heat up as it's building up all of this helium and getting denser, and it's gotten brighter over time. Turns out a thing can happen where water can be hot enough to stay gas and high enough in the atmosphere to dissociate. Ultraviolet light, which would have been coming from a slightly cooler sun, can cause the hydrogen and the oxygen to split from each other. The hydrogen would then be lost to space. The sun has what we call solar wind, and it tends to strip hydrogen away from planets whenever possible. But the oxygen would still be there. And so we would have a whole bunch of extra oxygen on Venus. And Earth used that extra oxygen to create an ozone layer, which is, again, very important to protecting us from the sun. But Venus, it seems like something else happened. So again, on Earth, we could separate, and we have that can happen. We did have some dissociation. The hydrogen went off. The oxygen came back, made the ozone layer. It could also combine with carbon to make carbon dioxide. But on Earth, where things are constantly moving and constantly reshaping, we have a carbon cycle. On Venus, there isn't a carbon cycle. There isn't water anymore to store and hold onto the carbon. So this oxygen combines with all of that carbon. You get a lot of carbon dioxide, and you end up with a pressure cooker where the lid's not moving. It's not being taken off. So that pressure just builds and builds and builds and builds until you get this runaway greenhouse effect. We have, and by we, I mean humanity, have landed on the surface of Venus besides just flying by it with Mariner. This is a spacecraft called Venera. This was actually Venera 13, and it is the only spacecraft to have visited Venus. It was launched by the Soviet Union, but it didn't last very long. It landed on the surface, it took a couple pictures, and then it stopped working, which, it's 800 degrees, so it kind of makes sense that it stopped working. Venus has historically been important because it has helped prove that the Earth is not at the center of the solar system. Venus goes through phases the same way the moon does. You can have a waxing gibbous Venus, but that's only possible if Venus is going around the sun. So like Mercury helped to prove general relativity, Venus helped to prove the heliocentric model. This was Galileo who discovered it. Once he kind of had a telescope up and working, he noticed that Venus goes through these phases, which again would not be possible if Venus was going around the Earth and the sun was going around the Earth. We would only see crescents on other sides, but we don't. We see a gibbous Venus. And so we are able to figure out that the sun has to be at the center of the solar system in order for Earth to be able to see Venus in this way. Venus also transits across the sun, which is one of the ways we could calculate and figure out how far away Earth was from the sun. Venus will go in front of the sun and cast a little shadow. So this is like a time-lapse picture. And if we know how far Earth is from the sun, then we can figure out how far everything else is, thanks to Kepler's fancy rules that we saw last week. Some fast facts. You probably haven't written much down yet, but here's some fast facts about Venus. A day on Venus is longer than a year, which is a weird thing to think about. Venus spins really, really slowly. So one day on Venus takes 243 Earth days. So in 243 Earth days, the sun will rise once on Venus. A year is only 225 Earth days. So a little bit shorter than our year of 365. Venus goes around the sun once in 225 days, and it spins around on its own axis once in 243 days. Venus's mass is about 95% of Earth's mass. It is a 91% of the gravity of Earth. It's got a gravity of 8.9 versus Earth's 9.8. It's got a really small tilt. Our tilt, we've learned, was 23.5 degrees. Venus's tilt is only 2.6 degrees, which means it wouldn't have very extreme seasons. But, the whole planet's really hot. Venus is 109 million kilometers from the sun, which is about 0.7 AU. It has a density of 5.24 grams per centimeter cubed. So it's up there. It is one of the denser planets, but it's not the densest. It does not have any rings or moons, but it rotates backwards. Venus, every other planet, goes around the sun counterclockwise and spins on its own axis counterclockwise. Venus goes around the sun counterclockwise, the same as the other planets, but it spins on its axis clockwise. It goes opposite from all of the other planets. So pause and take a second to think about, why do you think that might be? Why do you think Venus would go backwards? And we'll talk about it more next week. Here are a couple of links. These slides are posted on Canvas. So here are a couple of links to videos that you might find interesting about Venus. And if you have any questions, things that I missed or that you were confused by, write them down, hold on to them, and next week we will come back and revisit it. This is a picture of Venus showing elevation. It's some false color added. So there it is. There is what you need to know about Venus. If you have any questions, like I said, write them down, hold on to them, and I will address them when we get back. Thanks for watching. I hope you have a wonderful day and enjoy your weekend.